You've seen a bug trapped in amber, a single fly held forever in a drop of gold. But some pieces caught more than one death. They caught the whole scene. A spider frozen the instant before its fangs close on a struggling wasp. Alien jaws locked around prey they will never let go. A tick still swollen with the blood of a dinosaur. 99 million years ago, tree resin didn't just swallow animals. It swallowed the exact moment one creature was eating another and sealed it in glass. And today, 5 pieces of amber that trapped an entire food chain. Amber is not stone. It began as tree resin. Thick, sticky sap that bled down a trunk and slowly hardened over millions of years into a clear golden solid. Most of the time it caught one small thing. A gnat. A single ant. A leaf. Even that is rare enough. But every so often the resin flowed at exactly the wrong second for more than one creature at once, while something was hunting, feeding, or being eaten alive. And it sealed the entire event, predator and prey together, in the same drop. Nothing decayed, nothing rotted, nothing moved. And here is the part that should unsettle you. Resin moves slowly, but it is patient and total. It doesn't kill in an instant. It flows over a struggling animal, fills the space around it, seals off the air, and then hardens, holding the body in whatever pose it died in. Legs still braced, jaws still open, exactly as it was. What follows are 5 times amber closed over a whole scene and held it, breath by breath, for 100 million years. Start in 2012, in a laboratory, where a researcher is turning a small piece of Burmese amber under a lens. Inside it, thin gold threads run in every direction. At least 15 unbroken strands of spider silk, still stretched exactly as they were the day they were spun. Tangled in those threads is a wasp, and a hair's breadth away, closing in, is the spider. The amber comes from the Hukong Valley in northern Myanmar, and it's around 100 million years old. Early Cretaceous, deep in the age of the dinosaurs. The spider is an extinct orb weaver named Geratoniphila burmanica. The wasp, a tiny parasitic species called Cascocilio incassus, had blundered into the web at the worst possible moment. Orb weavers build the classic wheel-shaped web, a trap of sticky spokes, and they read the world through the vibrations those threads carry. When something hits the silk, the spider feels it and comes running. That is precisely the instant this fossil captured. Not the calm of a spider at rest, but the surge toward a fresh catch. And it captured it in a medium that normally destroys webs entirely. Silk is thin, delicate, easily torn. To find 15 strands of it intact, still under tension, with 2 spiders and a wasp arranged along them, is almost absurd luck. What George Poyner and his colleague described that year is the only fossil ever found of a spider attacking prey in its own web. Not a spider sitting still in amber, a spider mid-hunt. The wasp is caught in the most helpless instant imaginable. Legs against the silk, body half-turned, the predator already looming over it, forelegs reaching. One more second and the fangs would have gone in. They never did. The resin arrived first. It poured over the web, the wasp, and the spider all at once, and stopped time a single beat before the kill, so that the bite is always about to happen and never does. And there is a detail that makes the scene stranger still. There is a second spider in the same web, a male of the same species. Living orb weavers are mostly loners. A rival male in your web is usually a fight, not company. This is some of the oldest evidence we have of spiders tolerating each other and sharing a web at all. So what the amber caught isn't just a hunt, it's a hunt with a witness. 2 spiders and a doomed wasp, all suspended in the gold, the prey waiting forever for a bite that will never land. It's a small, quiet piece of violence. The next one is far stranger, because the hunter doesn't look like anything alive today. For most of the last century, paleontologists kept pulling ants out of Cretaceous amber that made no sense. They had long, blade-shaped jaws that pointed upward instead of meeting side to side, and bizarre horns growing straight out of their foreheads. Scientists started calling them hell ants. Everyone could see the weapons. Nobody could prove how they worked, because you almost never find a fossil of an animal in the middle of using them. Then, in a piece of Burmese amber about 99 million years old, they found one doing exactly that. The ant is a species named Ceratomyrmex ellenbergeri. Locked in its jaws is a baby. The nymph of an extinct insect called Caputoraptor elegans, a distant relative of the cockroach. And the way it's holding on finally answered the century-old question. The ant's scythe-like mandibles don't close sideways, the way the jaws of every living ant and nearly every living insect do. They swing upward, pinning the prey against that horn on the ant's head, a trap that snaps shut vertically, blade rising to meet bone. The little cockroach relative is clamped between the two, held exactly where it was caught. Hell ants weren't a single oddity, either. They were a whole extinct lineage that thrived for millions of years across the Cretaceous, in a startling variety. Some with straight tusks, some with scooped, trap-like horns. One even reinforced with metal, its headgear strengthened with traces of iron. They ruled these forests, and then they vanished completely, leaving no descendants at all. Every living ant comes from a different branch entirely, and the prey tells its own quiet story. Caputoraptor was itself a strange evolutionary experiment, an insect with a body edged like a pair of scissors, and the individual pinned here is a nymph, a juvenile, small and soft, caught before it ever had the chance to grow up. The team that described it in 2020, led by Philip Barden, kept coming back to how vanishingly rare this is. Fossilized behavior almost never survives. Predation caught in the very act is rarer still. Most extinct animals we only ever meet as still, empty bodies, and we spend decades guessing what they did with the strange equipment on their heads. Here there is no guessing. The weapon is buried in the victim. You are looking at the answer. And think about the moment it froze. The ant lunged, the jaws came up, the horn came down, the prey was pinned. And in that exact configuration, before the ant could feed, resin rolled over both of them. 99 million years later, the grip has never loosened. The jaws are still shut. Whatever this creature was in the middle of doing, it is technically still doing it. And if a predator pinning its prey unsettles you, the next piece of amber raises the stakes, because this time the thing being fed on is a dinosaur. In 2017, a team led by Enrique Peñalva published something that reads like a scene cut from a monster film. In 99-million-year-old Burmese amber, they found a hard tick, the same kind of blood-drinking parasite that latches onto animals today, and it was gripping a single feather. The feather did not come from a bird. This is the age of dinosaurs, and the feather belonged to a small feathered dinosaur, a theropod, which means this tick was doing to a dinosaur exactly what a tick does to a dog or a deer now, clinging to it, drinking from it. We can't say which dinosaur. A lone feather only tells you so much, but the relationship is unmistakable. A parasite and its dinosaur host, sealed in the same drop of gold. Ticks are old, far older than this amber, but almost everything we knew about their earliest victims was guesswork, because parasites and their hosts hardly ever fossilize together. That is what makes the feather so important. It isn't a modern feather that fell in by chance. Its structure matches the plumage of the small, fuzzy, feathered dinosaurs that scurried through these very forests, the same broad group that would eventually give rise to birds. For the first time, the parasite and the kind of animal it drank from were locked in a single frame, and there was nothing left to interpret. The tick had chosen a dinosaur, and the amber wrote it down. That alone would be enough. But the same study held more. 2 other ticks belonged to a brand new extinct species, and the researchers gave it a name worthy of it. Dinocraton draculae, Dracula's terrible tick, one of them had fed. It was bloated with a blood meal to roughly 8 times its normal size, a fat, engorged body frozen in the middle of digesting its last host. And before anyone asks, no, that blood cannot be used to bring anything back. Ancient DNA doesn't survive tens of millions of years locked in amber. The Jurassic Park version simply doesn't work. What survives is the shape of the crime, not the blueprint to repeat it. Then there is one more layer, and it's the one that turns a parasite into a scene. On those ticks, the scientists found tiny hairs shed by the larvae of skin beetles, insects that live inside nests, cleaning up shed skin and fallen feathers. The presence of those hairs suggests these ticks lived where their hosts nested. So the amber didn't just catch a parasite on a dinosaur, it caught a hint of the entire household. The feathered dinosaur, the ticks feeding on it, and the little scavengers working the nest floor beneath them. A dinosaur, its parasites, and the things that fed on the leftovers. 3 links of a food chain in a single stone. And yet the next entry may be the most disturbing of all, because the killer isn't an animal at all. In June 2025, researchers described 2 pieces of Burmese amber, both about 99 million years old, that don't contain a hunter and its prey. They contain something worse, a host and the thing growing out of it. In the first piece is a young ant. Erupting from its body is a fungus, a species newly named Paleoophiocordicep gerontoformicae. In the second is a fly, with a different fungus, Paleoophiocordicep ironomiae, breaking out through its head and body in fine, spore-bearing stalks. If that sounds familiar, it should. These are ancient relatives of the fungus behind the modern zombie ant. The one that infects an insect, spreads through it while it's still alive, hijacks its behavior, steers it to a spot ideal for spreading spores, kills it there, and finally fruits out of the corpse. That is what these fossils show, caught mid-process. The fungus has eaten the insect from the inside and pushed its reproductive structures out through the body wall, and at that precise instant resin sealed the whole grim transaction in gold. The team, led by Yu Huizhuang, understood what the age of the amber meant. This kind of mind-bending, body-hollowing parasitism was already running its course in the age of the dinosaurs. It is not a modern horror. It is at least 99 million years old, and it was probably already ancient then. In living forests, you can find the end of this story on almost any humid day. An ant clamped to the underside of a leaf in a rigid death grip, a pale stalk rising from the back of its skull, raining spores down onto the trails its own colony walks. The fungus doesn't simply kill. It marches the host to the perfect height and humidity to infect the next victim, then locks its jaws around a leaf vein and anchors it there to die. Finding the same strategy, already perfected in the age of dinosaurs, means this hijacking of another creature's body is no recent trick. It was old news to the Cretaceous. Whole generations of insects had already been turned into unwilling gardens for something growing inside them. Sit with the sequence for a moment. An insect is infected. It doesn't know. The fungus grows inside it quietly, taking it apart while it still walks around carrying its own killer. By the time the stalks emerge, the animal is already a shell, finishing the fungus's work for it. What Amber caught here isn't a predator eating prey in one clean bite. It's something slower and colder. A life being used up and rebuilt into something else. Stopped and preserved at the exact second the new thing broke the surface. And that is only one insect and one fungus. The final piece of amber didn't catch a single relationship. It caught an entire world. In 2019, a team led by Ting Ting Yu described one lump of Burmese amber, again about 99 million years old. That should not be possible. Sealed inside it is an ammonite, a marine animal, a coiled cousin of squid and octopus, the kind of shelled creature you dig out of ocean rock, not out of hardened tree sap. It is a juvenile, only about a centimeter across, its shell empty and packed with sand. An ocean animal, inside amber made by a land tree. That single contradiction is the whole story, because the ammonite is not alone. In the same piece are sea snails, more creatures of the ocean, and crowded around them is a whole cast of land animals, mites, spiders, a millipede, cockroaches, beetles, flies, a wasp. More than 40 individual creatures in one drop, marine life and forest life pressed together in a single golden block. Here is how it happened. The resin-oozing trees grew right at the edge of the sea. Just below them lay a beach littered with empty shells. The ammonite and the snails had died long before, their soft bodies already gone, only the shells left behind in the sand. Ammonites ruled the ancient seas for hundreds of millions of years, drifting and hunting in their coiled shells, and then died out alongside the dinosaurs. We know them almost entirely from stone, flattened spirals pressed into rock on old seabeds. To find one in amber breaks every rule of how fossils are supposed to sort themselves, because sea creatures and forest resin belong to two different worlds that should never touch. This single piece is the proof that, just occasionally, they did. The shell had come up from the tide line. A wave, a storm, or a scavenging animal had carried it a little inland, into the reach of the dripping trees. Living insects and spiders crawled and flew over that same shoreline. And when the resin bled down the trunk and spread out across the beach, it took everything in its path, the living forest bugs and the long-dead seashells alike, and locked them into one mass. So this piece isn't a snapshot of a single hunt. It's a cross-section of an entire vanished coastline, the forest, the shore, and the sea, and the animals of all three, caught in one accident of sap. A whole food chain, from the crawling scavengers of the leaf litter to the shelled swimmers of the open water, held in something small enough to close your hand around. And that is the thing about amber. It does not preserve what we would choose. It preserves whatever happened to be there in the wrong second, and it keeps it perfectly. Almost none of these were found on purpose. They came out of mines in northern Myanmar, out of raw blocks of amber cut open one after another, each split revealing whatever the resin happened to swallow 100 million years ago. Most pieces hold nothing at all. Many hold only a bubble of trapped air or a fleck of ancient dirt. A few hold a single insect, a wing, a leg, and a very small number hold a moment. A kill, a bite, a parasite, a whole shoreline, sealed the instant it happened and left waiting, in the dark, to be cut free. There are more of them out there. Blocks nobody has opened yet, scenes nobody has ever seen. Somewhere in a drawer, or still underground, is the next piece of amber that stopped time in the middle of something terrible. And that is the strange promise of this stuff. Every other kind of fossil is a body, a bone, a shell, an impression left after everything soft has rotted away. Amber is different. Amber is a moment. It doesn't hand you the animal so much as the second the animal was living, or hunting, or dying, kept so completely that the silk is still tight and the jaws are still shut and the parasite is still swollen with its final meal. Each new block that gets split open is a coin flip against 100 million years, and every so often it comes up as a scene no one was ever meant to witness. If you want to see what comes out of the gold next, stick around and subscribe.